Welcome. In this video I'm going to show you how you can perform a Bowker test or McNemar-Bowker test using Excel. I'll be using this as my example. It's a cross table with, let's say this was after and this was before. So we have people who saw indicated their brand preference before and after, and 20 people didn't change from A to A. But for example, 5 people first liked brand A, and after seeing a commercial, they went for brand C. Now, the most tricky bit is this one up here, and that's what we're going to start with. And I'm going to start with the brand B versus A, so this cell. And what this scary looking formula says is that you take this value and then you subtract its mirror, so the other way around, this 3. You square that result and then you actually divide that by the sum of those two. So we should get here 10 minus 3 equals 7 squared is 49, and then divided by 13. But in Excel that's becoming a little bit trickier, so let's get started. We start with an equal, then open the parentheses, and the first one is simple, that's this cell up here, and then minus. And now we need to look up this mirrored cell, which is going to be done by using an index. So index, then we select the entire cross table, which is this one. F4 puts in the dollar signs everywhere, so we can later on copy paste without any problems. Now the row should actually be now the row of brand B. So what we're going to do is we're going to use a match, and I want to match this value because that's the column, and I'm going to use F4 twice now to block the row number here, and it needs to look that up in these rows, so that way the column actually becomes the row. Then press F4 again, so it actually blocks all of those, and then select a semicolon or comma depending on your system settings, and a 0 because we want an exact match. Then we want to have as a column the row, so we need to look up this brand A and then press F4 1, 2, 3 times so it blocks the column, and it needs to look it up in these, and that's this one up here, and here we want to block the rows and the columns actually, so F4 a few times, and again an exact match. Then we close the match, we close the index, and we close the numerator for the function, and we square the result. It needs to be divided by, and then open and close parentheses, by this whole thing again, but then with a plus. So I'm simply gonna copy all of this up here, Ctrl C, paste it in here, and then the only thing I need to change is here a plus. Now we have a very long formula, but it should actually work. Press enter and we get our results. You can now copy and simply paste this entire formula, and it should give us the results. Now notice that here it will be of course a 0 because we're not actually comparing anything there. I put down below here for you one of those formulas, so if this went all too quick for you, you can actually have a look at this, pause the video and use it. That would be the one for E4, so would be the E14 one. Then we can finally determine the chi-square value, which is simply actually the sum of all of the ones from the previous step, but only if the row number is smaller than the column number. So we're not going to be using the diagonal at all, so let's make that dark gray. And we also won't be needing this one because here the row number is not smaller than the column number, and also not here, and also not this one, and not this one, and also not this one. So we're going to gray those out, and that gives me here the chi-square value, which is simply now this one plus that one plus that one. 13.77. Then for the degrees of freedom, we need the number of rows times the number of rows minus 1s divided by 2, which should be the same as if you would do it for the columns, because this is paired. So if we say that there are 3, so we get, in this case, equals, well, perhaps we should add number of rows somewhere, number of rows, which is 3. That's a number you have to actually fill out, or you can use a count A or something, but I don't think that will be the biggest problem. And then you can say equals the number of rows times, and then again the number of rows minus 1, and then divided by 2. So in this case that gives us 3. And then for the significance, there are a few different ways. You can use equals 1 minus, and then the new function chi-square dot dist, and then use the x, which is the chi-square value, and the degrees of freedom, which was 3, and that should give you a semicolon true for that we wanted cumulative, and it gives a 0.003. You can also use the old chi dist function, which is actually a right-tailed, so you only need the chi-square value and the degrees of freedom. And if you immediately want the right-tailed using the newer version, it's .dist.rt from a right-tail, and then you only need to fill out the chi-square value and the degrees of freedom, and there we have it. They all give the same result. And that's how you can do a Bowker test using Microsoft Excel.